Hello, everyone. So we are gonna prove a actually relation that we usually use. So it's basically when you have two lines, and then they are perpendicular, then their slope product should be -1. Okay. So this is what we are gonna kind of prove it. So, but just make sure you understand, like when you have two lines and then their slope, when you multiply, you get -1 if they are perpendicular. So, or if their product is -1, then you can conclude they are perpendicular. So you can go with either way, okay? But let's actually see why that's the case, right? So to do so, I'm gonna start with basic like figure, and where I will use my origin as one of the points. But if you like to use some other points, and you can actually make it general, which is doesn't make any difference. We have a really nice term in math we use, which is called without loss of generality. So just another way of saying that it doesn't really matter what points you actually use in our case, okay? So if I want to start with the origin, because that's kind of easier to deal with in general, okay, so I'm going to name this is 0, 0, right? That's something. And I will need two lines. Okay, so let's take one line is passing through origin in a way that maybe something like this. Okay. And then let's say another line also goes through origin, and then it will be something like this. Again, I choose my origin as one of my points to make that calculation simpler. But you can do this any points, which doesn't make any difference, okay? That's basically what I meant by without loss of a generality, okay? So now we have two lines, okay? This is my line, this is line. And then I'm gonna say the slope of this guy is like 2, and then the slope of this guy is m1. So slope is just, if you remember, is just the change, the ratio of the change of y's divided by change in the axis. Another way of saying that, rise over run. Okay, so some people remember like difference of the y's over difference of the x's. So you can change like y2 minus y1, x2 minus x2, which will give the same thing. But this is something we call slope. That's just gonna be a number, and then we usually use m. That's why I said m1 and m2. And now what I will do, I will just get another line passing through these two. But before I do this, I just draw these two lines in a way that looks like 90 degrees, okay? Which I'm gonna kind of need to use it and then get the -1 relation if they are perpendicular. So let's assume this is a 90 degrees, okay? And then there are a couple ways to prove, and then I'm gonna just use the Pythagorean and distance formula, but there are other ways. Maybe you can use a similar triangles as well. But for now, let's not deal with that. So if I drop this line, which is my vertical line, okay, then this is gonna be 90 as well. So I just draw this line in a way that the distance between the origin and this point is gonna be 1 unit to make our calculation simpler. But again, if you choose something else, that is also okay, but I'm gonna go with this is 1. Okay, this is 1 unit. So this is like, let me call this is point O. Okay, I'm gonna name this right here. And I'm gonna call this is A, and let's call this is B. So since the slope was rise over run for this line, if the slope of this line is m2, so the m2 is equal to rise over run. So the run is basically this distance, which is 1 unit. That's I chose intentional, so I can actually get the rise in terms of the slope with a nice number. So the rise over 1 is m2, meaning that this guy should be m2, which means this distance is m2 units. Okay, so if I call this is h, so ah as a distance is m2 units. And similarly, the slope of this line, I said m1. So that is also a rise over run. Again, this is going to be my rise, the change in the y direction, divided by run. So which means this distance hb is m1 units. Okay, so as soon as we have these, maybe it's better to write the coordinates because I'm going to use the distance formula. So the point A, you know, the x coordinates is right here, so which is going to be 1 unit. And then the y coordinate will be this distance, because if you like draw this horizontal line, so the y value will be right here for point A. So that's the same as this one, so which is m2. So the coordinates of A, 1 comma m2. And then similarly, the x coordinates of B is 1 unit, and the y coordinates will be just m1. So 1 comma m1. Okay, so I hope that makes sense so far. So I start with my graph. I draw in a way that the angle right here is 90 degrees, and my goal is to show if the product of m1 and 2 is -1. Okay, but to do so, I will use the Pythagorean, because Pythagorean is like, you know, this leg and then this leg, when you square those two and add them, so you will get the square of this one, right? So let me write that first. By Pythagorean, so we have OA squared plus OB squared is equal to AB squared. But the problem is I don't really know these distances in terms of those like m1 and m2s. But there is something we call distance formula, which is actually one application of Pythagorean. But I'm not going to dive into how we get that formula by Pythagorean, but it's good to know that as well. So the distance formula was something like this. So you take the difference of the x's when you have two like points and square it. And then you take the difference of the y's and you square that as well. When you take this quantity like sum, you take the square root, and then this is called difference between 2 points. Okay, so I'll use this one in our case. Okay, so if I take the distance between O to A, because I need that, so distance between A to O or to A, whatever, is, you know, the x coordinate is 0, x coordinate is 1, so that means 1 minus 0 is the difference of the x's. I need to square. And then y is 0 and m2. So that should be m2 minus 0 squared. Okay, so we square that. And then we take the square root of this whole quantity. Okay, that is something. And then the BO, which is this distance, is going to be similar. So the x is 1, x is 0. So the 1 minus 0 squared. And then m1 and 0, the difference of the y's, and you take the square as well, and the square root of that quantity. This is gonna be whatever quantity you get from here is gonna be the length of the right triangle, and the BO is also other length. All I need is just AB now. So if I take the AB as well, right? So the coordinate is 1, so we take the difference. Most people will say this, we don't really need that difference of the x's for this case because there is no change in the x direction, so that's just 0, obviously. And plus the m2 minus m1 or m1 minus m2. But when you take the difference of those, which doesn't really make any difference because at the end you are going to square. So if you get negative, when you take the difference, you square, you get positive. If you get the difference of positive, so you square, you still get a positive. So that means m2 minus m1 or m1 minus m2 doesn't really make any difference. Okay, so now we got these 3 sides, which what we were looking for. But let me continue right here. So I said OA squared, which means this quantity is, the whole thing is AO, but I need to square this one. When you have a square root, and if you want to square that, so if you square this distance, you take this square root out of the way. So which will be 1 minus 0 squared, which is just 1. And then m2 minus 0, m2. And then you got squared. And then there is no square root anymore because the AO is actually square. So I use this equation right now, which is my Pythagorean. And plus, the same reason 1 minus 0 is square is just 1. And then m2 minus 0, m1 minus 0, m1. You take the m1 square. That should be equal to AB squared, which is going to be this quantity, but AB is the square root of this. If you square that square root, so the square root and square will cancel, you got just inside, which is 1 minus 1 is 0. Let me write that anyway. And then M2 minus M1. Okay, to the second power. So this is way better than what we had. So let's expand the right side so we can see some sort of cancellation. So if you want to write M2 minus M1 to the second power, you can write this binomial twice and multiply, or you can use the square of binomial, which will be M2 squared minus 2 times M2 times M1 plus M1 squared. Again, if you don't get this part, so please write this binomial twice and multiply. So you should be getting this one. So 1 plus 1 is 2. And then you have M2 squared plus M1 squared. And we see that these guys will cancel, M2 squares and M1 squares will cancel. And then you have only 2 equals -2 times M2, M1. If you divide both sides by, let me write this first. So 2 is equal to -2 times M2 times M1, divide by -2, so you will get -1 M2 times M1. So you can change those, M1 times M2, which is what we were trying to prove it. So I hope that makes sense. Basically, when you have two lines that is not vertical, okay, and if you multiply those slopes, the slopes of those two lines, if the product is -1, then the line should be perpendicular. Or if if you do have two lines are perpendicular, then their slope multiply to get -1. Okay, so that's basically what we prove. So again, there is another ways to prove this as well, but this is actually not too bad because we don't use any fancy tools for this problem. I mean, for this approach. Okay, so I hope that makes sense. I'll see you next time.